Deployment is where compiled contract code becomes a usable address on Besu. In this module, we'll connect to the right network, configure accounts and chain settings, automate deployment with Hardhat or Truffle, and verify success through transactions and receipts. You've already built the key layers: Besu fundamentals, architecture, permissioning, privacy, and a working development setup. Now we'll turn that foundation into practice by deploying smart contracts and validating their behavior on a Besu network. Deployment begins after compilation, when the smart contract has become bytecode plus metadata. A deployment script wraps that bytecode in a transaction, signs it with an account key, and sends it to Besu through JSON-RPC. Besu validates the transaction, runs it in the EVM, and records the resulting contract state. Once the transaction is finalized in a block, the contract has its own address, and the receipt gives you the reference needed to call it. Before deploying, be clear about your target network. A local chain is forgiving, with fast resets, easy debugging, and minimal risk. A consortium or private network adds shared configuration, especially chain ID and RPC endpoints. Permissioned environments add another gate. Only approved nodes or accounts may deploy. Public Ethereum-compatible networks are the highest stakes, because gas costs real value and keys need production-grade protection. Your deployment tool talks to Besu through JSON-RPC. That endpoint is the doorway for sending transactions, reading block data, estimating gas, and checking receipts. Most setups use HTTP for request-response calls, and WebSocket when tools need subscriptions or live updates. The tool configuration must match the node's URL, host, port, and enabled APIs, such as ETH, NET, WEB3. In enterprise networks, treat RPC as a privileged interface. Restrict it, secure it, and expose only what is needed. Chain ID is part of the transaction signature, so it determines where that transaction is valid. This prevents a transaction signed for one chain from being replayed on another. Besu private networks often define a custom chain ID in Genesis, and your deployment tool must use that exact value. Do not confuse it with a friendly network name or even the peer network ID. If the IDs differ, deployments can fail before the contract ever runs. Deployment is not just a code action, it is an account action. The deployer signs the transaction, pays gas, and may become the first owner or administrator of the contract. That makes key handling a security boundary. Never hardcode or commit private keys. Load them through environment variables, a key vault, or an external signer. Before deploying, confirm the account is funded, permitted on the network, and is the signer you actually intend to trust. Constructor parameters are the values a contract receives at deployment before it ever runs in production. They might set the owner, token name, initial supply, limits, policy rules, or addresses of related contracts. The deployment script passes these values, and they are encoded into the transaction data. Because some state may be immutable, a bad address or wrong unit can be permanent. That is why validation scripts and approval reviews matter in serious deployment workflows. Hardhat can treat Besu like any Ethereum network because Besu exposes JSON-RPC and runs the EVM. The key is the custom network entry in Hardhat, config.js. Point it to the Besu RPC URL, set the correct chain ID, provide the deployer key, and tune gas if needed. Your deployment script stays repeatable. Then run npx Hardhat. Run network Besu and Hardhat signs the transaction and sends it to the Besu node. Besu does not require one specific deployment framework. With Truffle, deployments are organized as migration scripts, which define order and dependencies between contracts. The provider configuration points those scripts at the Besu JSON-RPC endpoint, using the correct network or chain ID. As contracts deploy, artifacts capture the ABI, bytecode, and metadata. The same pattern works with Foundry, Brownie, or custom Web3 scripts, so teams can keep familiar Ethereum workflows. A good deployment script behaves like a runbook, not just a bytecode sender. It loads the right environment configuration, selects the signer, and deploys contracts in dependency order, so later contracts can reference earlier addresses. After each deployment, it waits for the receipt, initializes roles, permissions, settings, and relationships, then saves artifacts like addresses, ABIs, and transaction hashes. The payoff is repeatability. The same process can run safely across development, staging, and production. Besu networks. Under the hood, deploying a contract is a transaction with a larger payload, the bytecode. Besu checks the transaction envelope before it can enter a block. The gas limit must cover creation work, not just later function calls. Fee fields must match how your network is configured. The nonce must be the next number for that sender with no gaps. And even private networks enforce block gas and contract size limits, so oversized deployments can still fail. Once the deployment transaction is sent, start with the transaction hash. It is your lookup key for everything that happened on chain. The receipt is the proof record. A status of 1 means the deployment succeeded. The block number and confirmations tell you how settled it is. Gas used shows execution cost. Most importantly, contract address is the new instance you will interact with. For contract creation, 2 is usually null because no existing contract was the recipient. Now the contract needs to prove itself on the actual Besu network. Start with read calls, such as checking the asset registry owner and initial configuration. Then send a small controlled transaction, like registering one test asset, and confirm the state changed. Next, inspect the emitted asset registered event. Finally, verify the application is using the same contract address, ABI, and network settings you just validated. You can now take smart contract code from configuration to deployment and proof. Correct RPC, chain ID, signer, gas, and parameters make Besu deployments reliable. Tools automate the workflow, while hashes, receipts, addresses, and logs verify the result. Next, you'll connect deployed contracts to applications with Web3.js or Ethers.js.